In this presentation, we are going to derive two expressions. One is called RO. This expression of RO, that one helps you to find out the value of spatial resolution. And then one more expression called theta. That theta, that is also called as angular resolution in the case of optical instruments. Both RO and theta, both spatial resolution and angular resolution values are very important to find out the value of resolving power of any optical instrument. So our aim is to derive the value of RO and theta. So let's start from the diffraction pattern which is observed with the help of rectangular aperture. Look at the diagram. Here one rectangular aperture is kept here. That rectangular aperture is illuminated by the red color monochromatic light. After the diffraction effect, the diffraction pattern is observed on the screen, and on the screen we are able to observe the central maxima in the central part of the diffraction pattern. On either side of the central maxima, we are able to observe two minima. They are called as first minima. Okay, so after first minima, we are able to observe the bright band, dark band, bright band, dark band, like that alternatively it is formed. The most important part of the diffraction pattern is central maxima and first minima. To observe the central maximum or first minimum, the condition is A sin theta is equal to lambda. But in most of the optical instruments like telescope and microscope, the shape of the apertures are circular in nature. When the circular apertures are illuminated by monochromatic light like laser lamp, the diffraction pattern will be appearing as shown in the photo. The central part of the diffraction pattern will be bright in nature, that is called central maxima. Around the central maxima, there is a region called first minima. The dark region around the central maxima is called first minimum. To observe the either central maximum or first minimum, the condition is A sin theta is equal to 1.22 lambda. These kind of concentric circles appearing in the diffraction pattern, they are called as Airy's discs. By using this Airy's discs, we are able to measure two important quantities called spatial resolution and angular resolution. So Airy's discs are very important to find out two parameters called RO and theta. This is one of the most important diagram which is given in the textbook. By using this, we are able to measure the value of theta and RO. Look at the lens. The aperture of the lens is taken as A, and RO. What is RO? RO is the radius of the central maxima, or you can call it as distance between the central part of the central maxima and the first minimum. And then F is nothing but focal length of the given lens. By using these parameters F, A, RO and theta, we are going to derive the expression for theta and RO. Here we know the condition for obtaining the central maxima in the case of diffraction pattern which is created by the circular aperture. The condition for obtaining central maxima or first minimum is A sin theta is equal to 1.22 lambda. Here angle value is too small, therefore since the angle is too small, we can eliminate sin. Sin, it does not have any significance, therefore it can be written as here sin theta, that one becomes theta. Therefore A theta can be written, 1.22 lambda can be written. Here we are able to obtain the theta. What is theta? The theta is clear, that is appearing here. That is called as angular resolution. Theta is called as angular resolution. Theta is equal to 1.22 lambda divided by A. Here this theta is called as angular resolution. In any optical instrument, to calculate the angular resolution, this formula must be used. Don't forget. Okay. Angular resolution can be calculated by using this expression theta is equal to 1.22 lambda divided by A. Here A is called as the width of the aperture. Here lambda is nothing but the wavelength of the light which is incident on the aperture. Now we are going to calculate the spatial resolution. What is spatial resolution? R0 is called as spatial resolution. From the diagram you can easily find out which one is R0. Okay, so here the next one is how to find out R0. From the figure, from the geometry, from the diagram we are able to get the expression for R0. How to get this? This arc length will be equal to theta into focal length. Therefore, RO is equal to theta into F can be written. Here RO is called as spatial resolution. Spatial resolution. All optical instruments, they will have both angular resolution as well as spatial resolution. Depends on the value of angular resolution and spatial resolution, we are able to calculate the resolving power. Always resolving power, that is a reciprocal of the resolution values. So now we will calculate the RO value. How to calculate RO value? Substitute the value of theta. Instead of theta, substitute 1.22 lambda divided by A into F can be written. So this is the expression from which spatial resolution of any optical instrument can be found out. If theta is too small means resolving power will be more. If RO is very small means, that is spatial resolution is very small. If it is less means resolving power will be more. So to calculate the angular resolution and the spatial resolution, these two formulae must be used. Okay.